Good day, engineers. So we are on our sample problem number 2 on the discussion of Mohr's circle. So still, this is for the course Foundation Engineering. So start natin yung discussion on sample problem number 2. So for our sample problem 2, so from the element shown, determine the following: maximum and minimum principal stresses, and B, the stresses on the horizontal and vertical plane, and plane when the element is not rotated at an angle shown. So, kung mapapansin natin, yung element natin is inclined. It is rotated at an angle 30 degrees counterclockwise from our horizontal. So, from this one, we have yung tumatama dito sa element na to or sa plane na to and dito sa plane na to, which are values na 190 kilopascal and a shear stress of 72 kilopascal. Then, yung tumatama sa plane na to na naka-inclined are 95 and a shear stress na 72 kilopascal din. So, this will be considered as SP2-1. So, as a given, we have the soil element shown in figure SP2-1. Then, we have the required, which are the maximum principal stress, the minimum principal stress, the normal stress at horizontal and vertical plane, and the shear stress at the horizontal and vertical plane. So for our equation, we will have the Mohr's circle procedures and its concepts. So to solve this problem, kunin ulit natin yung inclined element na given. So, kunin natin ngayon yung direction ng forces or ng stresses dun sa element. So, si 190 kilopascal which is acting on this plane, at saka dito sa plane na to, is towards the element or inward. So, ibig sabihin nun, this will be a compression for the 190 kilopascal stress. Then, kunin naman natin yung direction nung nag-a-act dito sa plane na to, which is the 95 kilopascal stress. So, as we can see, yung direction niya will be towards the element or inward din. So, ibig sabihin, that is also compression. So, this one is compression. So, since all of them are in compression, therefore, we take these stresses as normal stresses na positive. So, since positive yung normal stresses niya, kailangan naman natin kunin ngayon yung shear stresses. So, mag-start tayo sa shear stresses on this plane. So, to start, maglagay tayo ng reference point or dot inside the element. So, kunin natin kung ano magiging rotation nung nasa taas na stress. So, ang magiging rotation nitong stress na to na nasa taas will be a clockwise rotation. While yung nasa baba na stress will also be a clockwise rotation. So, ibig sabihin, if we plot that one into a Mohr's circle, that will be a negative shear stress. So, gamitin ulit natin yung reference point na yon in determining the direction of the shear stress doon naman sa kabilang side. So, for this one and this one. So, as we can see, kapag naglagay ulit tayo or ginamit natin yung reference point na yon for the stress on the left side, it will rotate counterclockwise. Pag ginamit naman natin siya on the shear stress on our right side, this one will rotate also as a counterclockwise. So that means yung shear stress na yon is a positive shear stress. So, as a summary, para dito sa mag-partner na to na normal and shear stress, we will have an ordered pair na 190 and negative 72 since the shear stress is rotating clockwise and since the 190 kilopascal force is in compression. Now for the stresses na to na magka-partner which is 95 and 72, we will have an ordered pair of 95 and 72 since 95 is in compression and 72 is rotating at counterclockwise. So, yan ngayon yung ordered pair na ipa-plot natin on our Mohr's circle. So, to plot that one on our Mohr's circle, since 95, since yung 95 is lesser kesa dun sa 190, so ibig sabihin, we are plotting the sigmas on the horizontal axis and the shear stress on the vertical axis. So, kung ganun, ito si sigma o yung first sigma and ito yung second sigma which is at this point. So, kung mapapansin natin, equal naman ng magnitudes yung shear stress natin. The difference is such that negative yung isa, positive yung isa. So, ibig sabihin, ang partner ni 190 is si negative 72. So, ibig sabihin, nandun siya sa quadrant 4. While 95 and 72 is in quadrant 1. So, upon determining yung location ng points natin on our coordinate system or our coordinate plane, we have to connect that one para mabuo yung diameter nung circle natin, and also we could create the circle itself using those points. So since we now have the diameter of the circle, we can now determine, or since we have plotted yung points on our Mohr's circle, we can now determine the values for the center of the circle as well as the length of its radius. Yung mga radiuses niya. So, to determine that one, punta ulit tayo sa midpoint formula. So, the midpoint formula will be sigma 1 plus sigma 2 divided by 2. Sigma 1 will be 190 kilopascal and sigma 2 will be 95. So, divide natin by 2 para lang tayong nag-average. So, the answer will be 285 over 2. So, that will be the value of sigma c. So, the coordinate of our center now will be 285 over 2, 0. Kasi, yung shear stress natin at the center of our Mohr's circle will be 0. So, upon determining yung sigma c natin, we can now determine yung radius of our circle by the distance formula or the center radius form. So, pwede natin gamitin to, yung dalawang points na to, or pwede rin natin gamitin yung points na to at ito. So, for our distance formula, we will be using r is equal to square root ng x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So, i-square root natin yon so we can have the radius. So, ang ginamit natin dito will be yung point na to at yung point na to. So, we will be using the center of the circle and the second point or the first point kanina. So, that will be 285 over 2, which is the coordinate of the abscissa of the center. Then, minus 190, which is ito. Then, squared natin yon plus 0 yung ordinate ng center ng circle and yung partner na ordinate ng 190 na abscissa is a negative 72. Calculating that the square root or the sum of that squares will be R is equal to 86.2569 kilopascal. Therefore, we have a radius na ito yung value. So, ngayon, since may radius na tayo ng ating Mohr's circle, we can now determine other parts of or other stresses in our Mohr's circle. So, sunod natin i-determine yung minimum and maximum principal stresses. So, to determine that one, automatically, yung nandito sa side na to will be our minimum principal stress and on the other side will be the maximum principal stress. Ngayon, unahin natin yung minimum principal. Meron na tayong radius ng circle. So, ibabawas lang natin yung distance na sigma c dun sa radius ng circle natin. So, that will be for the minimum principal stress. So, it will be sigma 3 is equal to sigma c minus r. So, we will now have sigma 3 is equal to the distance of the center or the abscissa of the center, which is 285 over 2 minus yung radius of the circle, which is 86.2569. Calculating that one, we will have the minimum principal stress equivalent to 56.2431 kilopascal. Ngayon, for our maximum principal stress naman, which is yung nandito sa side na to, or etong point na to, we can now have an addition of the radius of the circle tsaka yung abscissa na sigma c or yung abscissa ng center. So, for the maximum principal stress, we will have sigma 1 is equal to sigma c plus r. Substituting the values, we will have the 285 over 2 plus 86.2569 and calculating the sigma 1, we will now have 228.7569 kilopascal. Yan ngayon yung maximum principal stress natin. So, upon computing the principal stresses, we now proceed in determining our beta. So, yung beta na pwede natin kunin, pwede natin kunin yung nasa taas, pwede din natin kunin tong nasa baba. So, kinuha ko lang yung nasa baba kasi mamaya doon natin paiikutin kasi yung angle kasi sa kanya yung reference point nung angle theta na hinahanap. So, kunin natin yung beta na nandito. So, we can get beta by extracting a triangle which is a triangle ABC. So, extracting the triangle, which is shown here, ang height ng triangle or height ng segment AB is 95. We take this hypotenuse as the radius of the circle and yung length ng segment AC or CA is x sub 1. So, to get the value of beta, we will be using the sine function. So, that will be sine beta is equal to 72 over r. So, unknown yung beta natin. So, we will have the inverse sine of 72 over 86.2569. Calculating the value of beta, we will have 56.5863 degrees. So, this beta will now be used as a reference para makuha natin yung ibang stresses na hinahanap for our element. So, para ma-solve natin yung iba pang required on the Mohr'S circle, so, ang isa pang required natin will be the stresses if yung element natin is in upright position. Ibig sabihin, nakatayo na yung element natin or it is in a 90-degree position. Since yung given natin is an inclined element, we have to rotate this one to an upright position. So, kung mapapansin natin dito, it is inclined at an angle 30 degrees. So, ibig sabihin, kung gusto natin siyang ibalik into its upright position, kailangan natin siyang i-rotate clockwise. So, mula dito sa plane na to, which is tinatamaan nung stresses na 190 kilopascal, which is the normal stress, at yung 72 kilopascal na shear stress. So, to do it in our Mohr'S circle, so kakailanganin natin yung radius na nakakonect from center of the circle to the coordinate 190 and 72 kilopascal na shear stress. Kasi yun yung magiging reference point for our clockwise rotation since galing yan dito sa plane nung given natin na element. So, we have to rotate. Ito yung radius na nakakonekta sa center papunta dun sa 190 kilopascal and negative 72 kilopascal na shear stress. So, that will be rotated clockwise 30 degrees sa element. Pero pag nirotate natin siya on our Mohr'S circle, we have to double the 30-degree angle into a 60-degree angle. So, ibig sabihin, rotate natin siya clockwise, then you will have a 60-degree angle na reference rotation or angle of rotation. So, this 60-degree angle now will be located on this part. So, yung radius natin, inilipat natin on a 60-degree basis. So, ibig sabihin, yung hinahanap nating stress on the horizontal plane of the upright element is ito. So, pinapahanap din sa atin kung yung stress is on the vertical plane. So, ibig sabihin, that is a complement ng horizontal stress ng upright position ng element natin. So, kapag ilalatag natin siya on the Mohr'S circle, so 90 degrees galing ng horizontal plane. So, ibig sabihin, 180 degrees siya dun sa Mohr'S circle. Kaya mula dito sa point na to or sa reference radius na to, iikot naman ulit natin ng 180 degrees. Ito na ngayon yung hinahanap natin na stress dun sa vertical plane natin. So, to solve for the horizontal stress in the soil element na naka-upright position, so since meron na tayong 60 degrees, gamitin natin yung beta kanina na nakuha natin para makuha yung isa pang angle which is ito at i-note natin siya as alpha. So, kung mapapansin natin dun sa figure, we can get an equation na alpha plus beta plus 60 is equal to 180 degree angle. So, kung ang hinahanap lang natin is alpha, we could produce an equation alpha is equal to 180 minus 60 minus beta. Yan ngayon yung equation natin para makuha yung angle alpha. Substituting yung nakuha nating beta kanina, we will have 180 minus 60 minus 56.5863. So we will now have an alpha equivalent to 63.4137 degrees. Ito na ngayon yung angle alpha na magagamit natin to get the stresses in our horizontal plane. So, kung ito siya, we can create a triangle coming from this radius. So, ito yung triangle na mabubuo. We note it as triangle CDE. So, extracting the triangle CDE, we can produce this triangle. So, we note it as radius R, yung hypotenuse niya, then yung length ng segment EC is x sub 2, and yung vertical or yung height ng triangle natin is the tau or the tau xy. So, makukuha agad natin yung tau xy na to through the sine function since that is opposite of the angle alpha. So, using the sine function, we will have sine alpha is equal to tau xy over r. Since unknown si tau xy, arranging the equation, we will have tau xy is equal to r sine of alpha. So, substituting the values of the radius and the angle alpha, we will have tau xy is equal to 86.2569 sine 63.4137 degrees. Calculating the value or the magnitude of tau xy, we will now have 77.1362 kilopascal. Ngayon, itong tau xy or value ng tau xy na to is valid for this part and this part. Remember, opposite angles are equal. So this alpha is equal to the alpha for this one. Since opposite angles yun and supplement silang dalawa. And by the way, be careful for the sign of tau in this point. You are in the fourth quadrant. So that means kapag yung tau na horizontal ang hinahanap, that should be negative since you are in the quadrant number 4. And tingnan dito sa supplement niya na partner ni sigma x will be positive kasi that is in quadrant number 1. So now, after getting the shear stress, we can proceed in getting the length of segment EC or yung isang legs ng right triangle natin. So, we can get it through the cosine function or by using the Pythagorean theorem. So, let's just use the Pythagorean theorem. So, that will be the square root of r squared minus tau squared. Yan ngayon yung segment or length ng segment EC. Substituting the values for radius and tau xy, we will have 86.2569 squared minus 77.1362 squared. Calculating the values, we will have x sub 2 is equal to 38.624 kilopascals. So, ito ngayon yung length nung isang leg ng right triangle natin. Pero hindi pa siya yung hinahanap natin na normal stresses ng horizontal at vertical plane. So, para mahanap natin muna, ang unahin nating hanapin is yung sigma or yung normal stress nung horizontal plane natin. So, para mahanap natin yon, since that is a length sigma y, para mahanap natin siya, since meron na tayong length ng EC, we must subtract yung sigma c sa length EC para mahanap natin yung value or yung magnitude ng sigma y. So, Having that from our Mohr's circle, we can have sigma y is equal to sigma c minus x sub 2. Then substituting the values, we will have 285 over 2 minus 38.624. And calculating those values, we will have sigma y is equal to 103.876 kilopascal. It is positive kasi nandun tayo sa side na positive yung sigmas natin. Then, to calculate naman for the value of the sigma x, since nandun siya on the right of our center of the circle, so meaning this one should be sigma x. Ngayon, since parehas lang yung values nung alphas natin, so ibig sabihin, yung horizontal part ng segment EC is parehas sa horizontal part netong supplement or ng vertical plane. So, ibig sabihin, we could have the equation sigma x is equal to sigma c plus x sub 2. So, i-add lang natin kay sigma c yung x sub 2 na nakuha natin kanina since that is on the right side of our center. So, substituting the value for sigma c and x sub 2, we will have 285 over 2 plus 38.624. So, the value now for sigma x will be 45,281 over 250 kilopascal. So, this will now be the answer for the horizontal and vertical planes na nag-a-act dun sa soil element if it is in upright position. As a summary of our answers, we have the maximum principal stress, sigma 1 is equal to 228.769 kilopascal. Minimum principal stress of sigma 3 is equal to 56.2431 kilopascal. The normal stress at horizontal plane sigma y is equal to 103.876 kilopascal. Normal stress at the vertical plane sigma x is equal to 45,281 over 250 kilopascal. And the shear stress at horizontal and vertical plane is equal to the tau xy, which is 77.1362 kilopascals. So that will be all for the topic on Mohr's circle. So I would like to take this opportunity para magpasalamat sa Engineering Wins PH on featuring me in their Facebook page. So paki-like na lang and share yung page nila, which is ilalagay ko dun sa description box below. And I would also like to thank Engineer Ariel Morales. Siya yung prof ko sa TIP Manila sa Soil Mechanics and Dynamics. So pwede rin kayo mag-subscribe sa channel niya, which is nandun dun sa description below. And again, this is Engineer Rodolfo. Thank you for watching this presentation on Mohr's circle.